Okay, welcome to our presentation. We recreated EHR Safari. Data is contextual. This is CS598 Deep Learning for Healthcare, and I'm Reed Rogers, and my partner is David Scott.
Okay, so let's break down the three critical challenges that we tackled. Surprising distributions, timestamp issues, and bias in raw data. We used Postgres for Mimic3, Python for analysis. We used SQL queries to extract all the data, and libraries to load the Mimic3 locally, which we both did separately. We used pandas and matplotlib.
So in this section, we observed two different things that relate to heart rate. So the first you see is a bimodal distribution, which is surprising, and that's because of a confounding factor, which is neonatal heart rates being included in that distribution. And then the second is a large gap in terms of age, and that is because anyone in Mimic who is over the age of 90 is automatically assumed or marked as 300.
Inconsistent timestamps. So we learned that there are 11,886 times when an illogical timestamp stamps were entered into the data, usually because of data entry issues.
In this section of the paper, it's observed that abnormal white blood cell value counts in testing are at their lowest between 4 and 8 a.m. And without context, it would be unknown that this could be attributed simply to the fact that patients who were sampled during the time in green are more likely to be in that abnormal range. So you can see here our recreation, which mimics the results of Figure 5 from the paper.
Duplicate notes. Many notes had multiple versions. Some had 30 or 40 versions. And if NLP analysis don't know that there are multiple copies, then they're going to be showing rare words as not rare words, which is wrong.
Section 5.5 is about missing death date collection. So the initial observation was that the mortality rate appeared higher for white patients versus black patients, although we know this to be true. And the root cause of this turns out to be the way that a legislation change caused deaths to be counted, and that related directly to Social Security numbers. So you can see that we recreated the Kaplan-Meier curve using Mimic data here below.
So for this diagnosis, they use the LLM, and they tried to say that the LLM learned. They compared that with the diagnosis at the wrong time. They should have compared it with the final diagnosis, not the admitting diagnosis.
So section 6.2 looks at variation in data entry. The paper proposes that due to variation in how nurses or care providers enter data, that using that data could cause misrepresentation or improper takeaways because of that differing distributions between these things. So you see in an example here with heart rate values between day, evening, and night, the distributions vary. So without taking that into account, there could be some improper takeaways using that field.
Timestamp inconsistencies, which was actually caught up by the LLM. The ICU in time, it should be after the admit time, is now before the admit time, which is totally wrong. 1,500 minutes. Awful.
Our final novel extension looks at how data is pooled between different EHR systems. Our LLM proposed that we use dates, but unknown to the LLM, dates cannot be used in Mimic as a randomly offset. So we used item IDs for heart rate instead to distinguish between the systems. As you can see in the image to the right, the distribution between the two eras is quite different. And so that brings about the question, what has changed in the system and how can you proceed with caution?
So challenges and conclusions. What was easy? The fact that we already knew how to get the information. We're very familiar with Postgres, Python, all the tools. That was pretty simple.
What was hard was that without having clinicians around or people who understand the data set very well, context was lacking in some scenarios. So without that context, it made analyzing the data a little bit more difficult.
Thank you.
Thank you.